Hello class. Today we are going to be looking at three trig functions. Just so you know, this packet has both your notes for today as well as your homework assignment at the end on the last page. So please go through the notes, practice the examples here, and then complete the homework for tomorrow. The filled in key for both the notes and the homework is on the Moodle site under Chapter 10 Homework Keys. Today, as we talk about three trig functions, I want you first to be thinking about this over here, where when we talk about a right triangle, this red box means it's 90 degrees. Theta is the angle. It's an acute angle, which means it's less than 90 degrees. The side across from it is called the leg opposite theta. As I fill in the sine, cosine, and tangent, I'm just going to call that opposite, OPP. If I'm talking about the adjacent leg, the leg adjacent to theta, I'm going to call it ADJ. And as I talk about the hypotenuse, which is always the longest side across from the right angle, I'm going to call it HYP. If we want to use the sine of theta, from theta, we would always do opposite over hypotenuse. You should remember this from geometry. That is going to be the SO part of what you may remember as SOHCAHTOA. If we want to use the cosine, it's when we're going to do adjacent over hypotenuse. So that's the CA part. And then tangent to theta is always opposite over adjacent. So we use these three trig functions to help us solve right triangles. Until lesson 10.9, make sure that your calculator is in the degree mode. You have to go into settings on your home screen. And I would also encourage you to use documents, not Scratchpad. If you're using the Inspire calculator, so that you don't, because that's how your calculator reads it. Okay, now let's look at some examples. Suppose a flagpole casts a 22-foot shadow when the sun is at an angle of 39 degrees with the ground. What is the height of the pole? So they give me the picture, I just want to find the height. Sometimes you'll have to draw your own picture. We'll look at that in a minute. If this is my angle theta, according to what we talked about above, the h that we're trying to find is the leg opposite of theta, so that's the OPP. And the 22 is the leg adjacent to theta, so it's ADJ. What I ask myself then is which of the three trig function uses opposite and adjacent, and I remember that it's TOA. Therefore, I'm going to use the tangent. It's always tangent of the theta you're talking about, so tangent of 39 degrees equals opposite, which is h, over adjacent, which is 22. And now I need to be able to solve equations. This one would be the easiest type. All I have to do is move the 22 because I'm dividing by it. I'm going to multiply by it. You will need to know how to type that into your calculator. When I typed in 22 times tangent of 39 degrees, I got 17.8 feet. Quick reminder, as you're doing this section, because we are doing word problems, make sure you label units. Okay, so make sure you have feet in there. You can pause this right now, try example 1b. I will continue on with it so you can look back at it. This one has a little bit different algebra. Using the same example, what is the distance from the end of the shadow to the top of the flagpole? That's asking this diagonal, so I'll call that D. That's also considered the hypotenuse. Whenever I do this, I'm going to use the original numbers they give me. So if I'm doing a second problem for the same triangle, use the original numbers. So I'm going to use the 39 and 22 again. So in this case, I have adjacent and hypotenuse, which means I'm going to use the CA part. So I'm going to say that the cosine of 39 degrees equals adjacent, which was the 22, over the hypotenuse, which is D. That's what I'm trying to find. The reason that I would use the numbers they give me is because technically I rounded when I was finding the opposite side. Alright, now this one's the more difficult algebra. It's a two-step process. First, I do need to move the D, so since it's divided, I multiply. So D cosine 39 degrees equals 22, and then I divide by cosine 39 degrees. So D equals 28.3 feet. in theory, you could have done cross multiplication from the beginning. My two-step process would be the same as cross multiplication. So you could have put cosine 39 over 1. As we move on here, just a quick little note. It said the blink of an object, such as the sun above the horizon, so we're talking about this theta here, from the horizon up, is the angle between the horizontal base of the object and the observer's line of sight to the object. That is going to be called the angle of elevation. So oftentimes in word problems, they'll use the angle of elevation, and you need to know what angle that means. It's from the ground up. So let's look at example 2a and 2b. Again, we'll try 2a on as a group, and then we will have you guys pause it and try the second one on your own. This is one where we now have to draw our own pictures. The Sapphire Express chairlift in Winter Park, Colorado has a vertical rise of about 490 meters. Vertical rise would be straight up meters. Suppose the lift travels at an average 16.7 angle of elevation. So that's from the ground up. So if I draw my chairlift, remember this would be where my chairs are. That's going to be important in a minute. So this is 16.7 degrees, the angle of elevation. How many meters long is the ride? So because they're talking about the chairlift, I'm looking for this. So we'll call that M for meters. So now I process what I'm given. I have my theta, I have my opposite because this is the side across from, and then I want to find my hypotenuse. So I think about my three trig functions, and I know that SO has opposite and hypotenuse in it. So I'm going to say that the sine of 16.7 degrees equals opposite, which is 490, over hypotenuse, which we're calling M. Pause this for a second, see if you can solve this algebraically. You should have multiplied both sides by M. M sine of 16.7 equals 490. And then divided by sine of 16.7. So M is equal to 1,705.18 meters. Again, pause it, try example 2. What you should have seen is that to find this distance, the horizontal distance from the previous example, we want to find x. So now we're talking about opposite that was given and the adjacent, so we should use TOA. So I did tangent of 16.7 equals opposite, which is 490 over x, times both sides by x. I get x tangent 16.7 equals 490, and finally divide by the tangent. Type that into your calculator. Scientific calculators should work for this as well. 1633.26 meters. And always labeling our answers. These next two are a little tricky. I will not expect you to memorize one formula that we're going to use from geometry again. But we're talking about each side in a regular pentagon. As a reminder, a regular pentagon, equal sides, equal angle measures. That's not a very good drawing, but VIOLA, they have to go in order. They're saying each side length is 7.8, so they'd all be the same. And we want to find the length of the diagonal VO. Now you may notice that this does not appear to be a right triangle. So what we're ultimately going to do is cut this in half to make it perpendicular, and that will be a right triangle. So ultimately I'm going to be using this right triangle. This will be this, and then this is 7.8. The problem is I don't know any angle measures right now except for the right angle. So I need to find one angle measure. Well, one thing we learned in geometry is that because all 5 of these are equal, we had a formula to be able to calculate that. The formula for the angles in regular polygons was 180 times n minus 2 over n. Again, you're not going to be expected to memorize that, but so if I want to find an angle in a regular pentagon, which is what this is, I'm going to do 180, n is the number of sides, so 5 minus 2 over 5, which gives me 180 times 3 over 5. 180 divided by 5 gives me 36, and 36 times 3 is 108. So again, calculating that each of these angles is 108 is what that formula just did for us. Okay? Now, having said that, I cut this one in half. So I do 1/2 of 108, which is 54 degrees. And the reason that's helpful is because that gives me this angle measure. Again, you won't be expected to be able to do that, so that's why I went through that quickly. Ultimately, though, I wanted to find this right here, so I'm going to call this side x. Now I have opposite and hypotenuse, which means I know I want to use sine. So I have the sine of 54 equals opposite, which is x, over hypotenuse, which is 7.8. Multiply both sides by 7.8. I got x equals 6.3. But again, that only gives me half. Now I need to calculate the other half. Well, if this is 6.3, this is 6.3. So I got to do 2 times 6.3 for a total of 12.6 centimeters. So a little more complex there because we're using a lot more things from geometry that we haven't talked about recently. If we did it again in this case, you would do the same things. If this is A, B, C, D, E, you can draw it and try it, but ultimately your work should be sine of 54 again equals x over 15.4. When I solved that, I got x to be 12.5, and then I did 12.5 times 2, which is 25. All right, this next part, 2 special triangles. Label these as special right triangles. And we will go back to these tomorrow, because I'm going to teach you the way the book does, and then tomorrow we'll spend some time looking at them a little closer. The first special right triangle is when you actually just cut it in half. And so it's a 45, 45, 90. The pen's doing that weird thing. The 45, 45, 90 triangle. If that's the case, because these angles are the same, these side lengths are the same, so they always have to be the same, we'll call them S and S. And if those are S and S, you'd use the Pythagorean theorem, and this would be S root 2. Okay? So again, we'll walk through how we actually calculate these, and I'll put numbers in place of the S's tomorrow. The second special triangle is called the 30, 60, 90 right triangle. So this is the 90, the smaller angle up top here would be 30, and then the bigger one would be 60. And this one is a little more confusing than the other one. If I call my hypotenuse length S, and we'll talk about why tomorrow, then this would be S over 2. And then finally, this would end up as S over 2 square root 3. So again, you can see that one looks a little more complex, but we'll talk about tomorrow where that comes from. Having said that, if I use the 30, 60, 90 triangle to find cosine of 30, here's my 30. Adjacent is S over 2 times the square root of 3 on top over hypotenuse, which is S on the bottom. And so when I work that out, I would do S over 2 root 3 times the reciprocal of S, which is 1 over S, because when I divide by fractions, I multiply by the reciprocal. These S's cancel, and I'm left with root 3 over 2. Ultimately, we'll use these 2 triangles to get us to understand these 6 trig functions very quickly and easily. And these are ones that you want to know, so memorize them. As you can see, the sine of 30 is always 1/2. And then the cosine of 30 is root 3 over 2. Sine of 60 will be root 3 over 2, and cosine of 60 is 1/2. Notice that those two just kind of complement each other. They're the opposites. And then finally, sine and cosine of 45 are root 2 over 2. These will be 6 things that you use over and over and over again in your math career. All right, now that we have finished the notes, your job for the rest of the hour is to finish your homework. You'll see that I fit it all on the rest of this page, so it shouldn't take you too long. The answers are on Moodle. Thank you. Have a great day, and we'll see you tomorrow.